And welcome back. It's the 7th of February today. It is the higher plus 5 a day. I have my calculator ready, and let's go with the first question. Okay, so we have an identity question. So what it's saying is for all values of x, the thing on the left-hand side is equal to the thing on the right-hand side. So that means if I expand the right-hand side, well, that's going to give me, let's try not to do it in one go, let's do it carefully. So dx squared plus 4 times 2 is 8, so 8x plus 16 plus e, which is going to give me dx squared plus 8dx plus 16d plus e, where that is my constant. Then I can directly compare it. I'll write it in a different colour underneath. I can directly compare that to 2x squared plus cx plus 13. And by comparing those coefficients of each x squared x and the x to 0, I can see it must be the case. I'm going to write it over here so it's got a bit of space. It must be the case that d is equal to 2. That's the easy starting point. It must also be the case that c is 8 times d, so I'm looking at the x term here. So c is 8 times d. I know d is 2, so therefore c is going to be equal to 16. So far, so good. Then the slightly difficult one is this one over here. So I know 16 times d plus e is equal to 13. I know 16 times d is 32 because d is 2, plus e is equal to 13, so e is going to be a negative number. I need to take away 19, so in other words, e is going to be equal to minus 19. And that's the first question done. Good question, that. Next question. All right, using all 5 of the cards. So that's the important thing. So therefore, I know I'm going to be filling all 5 of the slots. So I don't have to go through the 1-digit, 2-digit, 3-digit different combinations. How many different odd numbers greater than 40,000 can be made? Well, the other thing about using cards is I'm not repeating numbers. So this becomes a slightly different question. So the first question is, well, there's 2 things happening, isn't there? So one is I need to be greater than 40,000. So it must either start with a 7 or an 8 or a 4, because any number after the 4 will make it greater than 40,000. Or it must end with an odd number, so it must end with 7 or 3. And the issue I've got is it can't start and end with a 7. So I'm going to have to treat these 2 things separately. So actually I'm going to do it slightly long way. I'm going to say it starts with either 8 or 4. So I've got 2 choices. So let's sort of put this in. So it starts with 8 or 4. So it starts with 8 or 4. I know it can end with either 3 or 7. So there's 2 choices there. Now I've used up 2 of the numbers, which means there are 3 numbers left to choose from for that one. There's 2 numbers to choose from here and just 1 number left over here. So in other words, if my starting number is an 8 or a 4 and I want it to be odd, which means my ending number is a 7 or a 3, there's 2 times 3 times 2 times 1 times 2, which is 4 times 3, which is 12 times 2, which is 24. There's 24 ways of doing that. Then I need to consider the situation where I start with a 7. So if I start with a 7, so let's again go 1, 2, 3, 4, 5. Well, if I start with a 7, there's only one choice to start with, and that's my 7. It also means there's only one choice to end with, which is my 3, because I've used my other odd number already at the start. So I've got odd number at the start, odd number at the end. But it still means there's 3 options here, 2 options here, and 1 option here remaining for each of my choices. So therefore, if I multiply these numbers together, well, 3 times 2 times lots of 1s is going to give me 6. Add together all these combinations, and that's going to give me 30 combinations overall. So tricky question, but ultimately falls out fairly sensibly as long as you take it slowly and think about what you have. Next question. Okay, so this is a question where I have velocity against time. Now, without reading the rest of the question, let's remember with a velocity time graph, the area gives me the distance and the gradient gives me the acceleration. So I'm guessing the next 2 questions are going to be based on those 2 things. So let's read them carefully. So first question, estimate. Estimate meaning I can't be precise because I don't know what the equation is and I can't integrate yet. So therefore that's all I need to do. The distance travelled in the first 8 seconds. Okay, that's an interesting one. So it just wants this first bit here. Now, there is definitely a quick way of doing it, which I could just divide this into one big triangle, but let's make it slightly more accurate. So what I'm going to do is I'm going to divide it into a trapezium and into a triangle. So what I need, and I'm going to have to zoom in here, is I need the y value here. Now, I mean, it's bad enough on an iPad, probably even worse on a screen, but each square is 0.4, so I'm going to say this is, and again it doesn't really matter, I'm going to say that's 9.6. And equally this is 12.4, 12.8, I'm going to say this is 13.2. Now, a good idea always to label what you're doing. So I'm going to call this area A and area B. So area A and area B. Area A is a triangle, so it's going to be a half times 4, which is my height of my triangle, times 9.6, which is the height as you look at it. And then B is going to be a half. Well, it's a trapezium, so the height, and again it's a horizontal height, but my height is 4, and then it's going to be 9.6 plus 13.2. And let's just get my calculator out. So that's going to give me 0.5 times 4 times 9.6, which is 19.2. And it's going to give me 0.5 times 4 times 9.6 plus 13.2, which is going to give me 45.6. And if I add these together, 19.2 plus 45.6 is equal to 64.8. Look at the diagram, it's in meters per second, so that's 64.8 meters. First question done. Next question, as I thought, estimate the deceleration. So, bit of an aside, so the change in velocity, so this is calculus language, with respect to time, so you might have seen this written as a change in velocity with respect to time, is what's known as acceleration. It's how my speed changes, or my velocity to be more accurate. Right, the way I'm going to do this is 12 seconds is here, and so I'm going to do my best job on an iPad, which won't be a great job, of drawing a line which roughly represents the gradient. So that's going to be as good as I can do. Now, as long a line as you can, because that means your error is likely to be less substantial. Then I'm going to note the coordinates. So the coordinates of this one is going to be 8 against 16. Zoom out a bit so I can actually write that. So 8 against 16. And the coordinates of this one down here are going to be, well, again, I've made this slightly easier for myself. So it's going to be 18 against 0, which in other words means I am going across by 10 and I'm going down by 16, and minus 16 over 10 is minus 1.6 meters per second squared. Actually, that didn't turn out too bad, did it? I don't really like these questions. They're on my list of least favourite questions, but that one wasn't awful. Okay, next and final question today. The set of values for x that satisfies a quadratic inequality is, write down a possible, this is a clever question. We've seen one like this before on a different day. This is basically a backwards question. So the way quadratic inequalities work is you solve them, you find out the three values. So in this case, it tells you it's minus 3 and 6. And then I want all values that are greater than 6 and less than minus 3. Then what I would be doing is I'll be solving the equation to get this. So in other words, those values could have come from x plus 3 and x minus 6, which if I expand that is x squared minus 6x plus 3x is minus 3x, minus 18. And then I want all values that are greater than something, so therefore it's going to be greater than 0, because those are the values I solve for. Nice little understanding question at the end, so well done if you got that. And as I said, well done if you got the others. Keep following. The questions are quite different each day now, which is always a bit reassuring. As ever, do like and subscribe, just helps the channel, helps the feedback, and I will see you for tomorrow. Thanks all.